Lesson 28. We're going to try and finish this up now, but I have a feeling we're not going to be able to with the last four examples. So, what we're going to do here is we're going to go ahead and do example 6 and example 7. Now, it tells us only to find the first three non-zero terms of the Maclaurin series. So, it's giving me this thing right here. And again, it might not be that bad to go ahead and take the derivatives, plug numbers in, but the first derivative of this thing will be a product rule, and I don't want to do that. That's too much work for me. So what I'm going to do instead is looking at my page 682 of the power series of elementary functions. I'm going to say that this thing should be equal to my e to the x power series. That's this thing right here. And again, this is my e to the x power series. Okay, and this continues on forever. I'm going to end that parenthesis. That's my e to the x. I'm going to go ahead and write that down. E to the x. What's my arctan? Well, I'm going to go ahead and write that down. Arctan of x. I'm going to write it down over here. Okay. My arctan of x is going to be a power series that is x minus x to the power of 3 divided by 3 factorial plus x to the power of 5 divided by 5, I'm sorry, not 3 factorial, just 3 divided by 5, minus x to the power of 7 divided by 7, plus x to the power of 9 divided by 9, minus dot, 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 dot. Okay, now I'm going to zoom this out a bit so you can see it all. This is e to the x, this is arctan. Now I want to know what are the first three non-zero terms. Okay. This actually seems like it might be very complicated, but in reality, it's a very simple problem. Okay, it's a very, very simple problem. Watch what I do. I want to multiply these things together. Okay, again, that's what I want to do. I want to multiply these things together. So, how am I going to do that? Well, if I start multiplying these things together, I'm going to do 1 times this, 1 times this, 1 times this, 1 times this, and so on and so forth. I know that seems to be a lot of multiplication stuff going on. Okay? But I only need the first three non-zero terms. So when I do 1 times x, that's very clearly going to be the only x term. And the reason for that is because when I do 1 times x cubed, this is going to be an x cubed term. If I try and do x times x, that's giving me x squared. It's no longer just an x term. So what I'm going to do is I'm going to go ahead and just do 1 times the first few terms, x times the first few terms, and then possibly x squared times the first few terms, and see what I end up with. Okay? And see what I end up with. So I'm going to go ahead and add these things together. I'm going to go ahead and draw a line down here. I'm going to go add, and this is going to be from the 1. I'm going to go ahead and put a 1 here. And I'm going to have from an x here, and then from the x squared over 2 factorial term. Okay, that's where they're coming from, me distributing this. Me distributing the 1 is going to give me x minus x cubed over 3 plus x to the 5th over 5. I don't think I'm going to need to go to the 5th. I might, but I doubt it. I have x's, I have x squareds, I have x cubes. Chances are I don't need to go any even further than that. So I'm going to leave it there. Okay, that's the first function piece. Okay, next I'm going to distribute the x. Now when I do x times x, I get x squared. Is there any x squareds in here? No. So what I'm going to do is I'm going to see if I can line that up somewhere else. Okay, but better yet, I'll just put it here, x squared. Okay, then I'm going to do x times this x cubed thing, and it's going to be minus an x to the 4th divided by 3. Okay, again, I have x times x to the power of 3 is x to the 4th over 3. I don't think I'm going to distribute to the x to the 5th, because that's going to be x to the 6th, and I said I probably wouldn't even need this 5th term, so we're going to leave that. Lastly, I'm going to look at this one right here, x squared divided by 2 factorial. I'm going to multiply it by x. That's going to give me x to the power of 3. I'm going to put that here. Divided by, now it's x to the power of 3. This is 3 times 2 factorial. This is 3 times 2 factorial, so that's really just going to be 6. I'm going to leave that there. I will then talk about x squared distributed to this. That will give me an x to the 5th term, so I'm going to go ahead and write that down. Minus x to the 5th, and I'm going to have 2 factorial times 5, which is just going to be division by 10. So I'm going to zoom this in a little bit closer so you can see it again. I just needed you guys to be able to see what I was doing. Now, I'm going to draw the line through here. X cubed, x fifth, x squared, x fourth, x cubed, x fifth. I need the first three non-zero terms. Are there any other x's? No. So I just have x. Then I have x squared because there's no other x squared terms. Lastly, I'm going to have just the x cubed terms because, again, I don't need anything more than the first three non-zero terms. And let's just make sure it's non-zero. I have negative x cubed over 3, and I have a positive x cubed over 6 and no other x cubes. Okay, so I'm going to go ahead and do this. Minus x cubed over 3 plus x cubed over 6. I need to add those two together, and I don't need anything else. Yes, this is technically the fourth power term, and I can write that in there. Yes, I can technically combine these terms, but I don't need to. So let me just go ahead and finish this. Plus dot dot dot. This is going to be equal to x plus x squared. And if I find the common denominator, this becomes 6 and 2. So I have a negative 1/6 x to the power of 3. Okay? Now I have a feeling I might have done something wrong here. Let me really quickly check my math. I did x times... I did 1 times this, 1 times that, 1 times that. I did x times that and x times that. And then I did a positive x squared. Oh, yes, I did screw that up. When I do positive x squared times the x, I should have x cubed over 2, not 6. So this should be a 2, and this should be a 3. This should give me 3 over x to the 6, and this just ends up being a positive 1/6 x cubed. Again, minor mathematical mistake. Again, minor mathematical mistake, but it would change the entire problem and screw everything up. Again, I'm going to leave that mistake in there. Again, it was the fact that when I multiplied through, I did this term times this term and didn't follow the rules. Okay, and this one here would actually be a 6th. Okay, be very careful when multiplying these things out. So, this is my end result right here. That's all I'm looking for. Again, is the first three terms of the series. Okay, well, if that's the case, let's talk about B for tangent. Now, I don't really know how to deal with tangent. I know arctan, I know arcsine, I know sine, I know cosine. Wait, I know sine and cosine. Tangent, isn't that really just the sine of x over the cosine of x? And I hope you see where this is going now. We know the power series for sine. We know the power series for cosine. So I'm going to have x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus x to the 9th over 9 factorial. And again, I'm going to write all those out. Minus dot 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 continues on forever. Let's do the cosine ones. Now the first one's going to be 1, and then I'm going to have minus x squared divided by 2 factorial plus x to the 4th divided by 4 factorial minus x to the 6th divided by 6 factorial plus x to the 8th divided by 8 factorial minus dot dot dot. Okay, now how am I going to deal with this function? Well, very carefully, you're going to distribute the division. You're going to distribute. This is not going to be easy, to say the least. Okay. I would really like to distribute this division, but because there's more pieces on the bottom, I mean, I'd have to take this thing and divide the x by it, and I have to take this. Sorry, I have to divide this thing up the x by this whole piece, then this piece by this whole piece, then this piece by this whole piece. Determining the overall smallest term will not be easy in that. Okay? What we have to do is return to good old-fashioned 1 minus x squared divided by 2 factorial plus x to the 4th divided by 4 factorial minus x to the 6th divided by 6 factorial. Okay? Dividing x minus x cubed divided by 3 factorial plus x to the 5th divided by 5 factorial minus x to the 7th divided by 7 factorial, and so on and so forth. And I have to use long division. How do I get rid of x? Well, by multiplying everything over here by an x. That will be my first term. Okay? When I multiply everything in here by x, I'm going to get x minus x cubed, cubed divided by 2, plus x to the fifth divided by 4 factorial. I'm going to go ahead and change that to the number it really is. 4 factorial is going to be 4 times 3 is 12 times 2 is 24. And then lastly, I'm going to go ahead and do this one right here, and that one's going to give me a x to the 7th divided by, and it's going to be 6 factorial. What we did in the last video, I believe, is 120 with a minus sign. Now I'm going to subtract all these, so minus, plus, minus, plus. These cancel out. What am I left with right here? Again, these are all x cubes. Well, this is a 6. Okay. So if I do the math here very carefully, adding these two pieces together, I'm going to get a positive 1 over 3 x cubed. Adding these two pieces together very carefully, again, 5 factorial being 20, is going to be a negative 1/30th x to the 5th. Again, very carefully doing this math. That's all I'm doing is I'm taking this number here, 1 over 5 factorial, and I'm adding to it or subtracting from it 1 over 20 or negative 1 over 24. And I'm saying I have x to the 5th of those things, or of those things x to the 5th. I'm not going to worry about the 7th because you'll notice that's my first term. If I do this one to get to the next term, okay, and then one more term, all I need to do is cancel out these next two terms. That's all I'm going to need to cancel out. So let's go ahead and do that. How can I get a 1/3 from this? How can I get a 1/3 from this? Okay, well, that means I need, starting with this term right here, what can I multiply this by in order to get this? Well, it's going to be a positive 1/3 x cubed. Okay, a 1/3 x cubed will give me this term. So I'm going to go ahead and do that. 1/3 x cubed. 1/3 x cubed times this is x to the 5th. X to the 5th, right? Again, x squared, x cubed is x to the 5th. And then 1/3 times a negative 1 over 2 factorial is actually a negative 1/6, is it not? Okay, when I subtract these or add those pieces, subtract these pieces, they cancel out. Add these pieces, I'm actually going to get a 2/15 x to the 5th, which is actually going to be our next term, right? Again, what do I multiply this by in order to cancel that term out? What do I multiply this by in order to cancel this term out? And that's what it's going to be. So this tangent over on the side here of x in terms of the first three terms is equal to x plus x to the power of 3 over 3 plus x to the power of 5, 2x to the power of 5 divided by 15. Okay? And that's it. That's my end result. In the next video, we will talk about the last two problems, series to determine sine squared from cosine, and the power series to approximate the next piece.